Conceptual development started in early 19th century when Sturgeon and Henry demonstrated that electricity could create powerful, controllable magnets essential for picking up and releasing various materials. Industrial applications started in 19th where electrically powered lifting cranes with electromagnets were being used for handling scrap, metal and steel, a significant improvement in industrial efficiency and use until modern time. The uniqueness of this product is because of its high volume efficiency in handling high volume movement of magnetic materials such as scrapyards, steel mills and shipyards compared to thread-wheel crane and hook and chain crane. The core of an electromagnetic crane is an electromagnet, a coil of wire or solenoid wound around a soft iron core. When DC current flows through the coil, it generates a powerful magnetic field, turning the iron core into a temporary magnet.
Now, let's move on to learning and understanding what is an electromagnetic crane and how it is related to magnetism. An electromagnetic crane is a specialized heavy lifting machine used primarily in scrapyards and steel factories. It replaces mechanical hooks with high-power electromagnets. Its functions is that it is able to handle bulk ferrous metals and also able to load and unload very fast and efficiently. It is very crucial for modern metal recycling because it impacts the human life. So, how does an electromagnetic crane works? The core of an electromagnetic crane lies in the concept of electromagnetism. When electric current flows through a coil, it generates a magnetic field around the coil. The strength of this magnetic field can be controlled by adjusting the amount of current passing through the coil. This phenomenon is the foundation of how an electromagnet operates, and the electromagnet is a crucial component of an electromagnetic crane. When an electric current flows through these coils, it creates a uniform magnetic field. We calculate the magnitude of this field at the center using this formula. B equals to mu R, mu 0 and I. If the current remains constant, increasing the number of turns in the coil on the crane will enhance the magnetic force. If the number of coil turns stays the same, increasing the current will also increase the magnetic force. In a crane, we don't use an empty coil. Instead, a ferromagnetic coil is inserted. When this material is inserted, the magnetic strength increases significantly because the permeability of iron is greater than air. This allows the crane to generate enough magnetic flux to lift heavy objects as heavy as a car.
I will present our device, which is the electromagnetic crane. This device works using electromagnetism. When electric current flows through the wire coil wrapped around the nail, it creates a magnetic field and turns the nail into a temporary magnet. First, watch this. When I connect the circuit, the nail becomes magnetic and attracts these mini staples. But when I disconnect the wire, the current stops flowing, the magnetic field disappears, and the mini staples fall. This shows that an electromagnet can be switched on and off unlike a permanent magnet. This is why real industrial cranes use electromagnets to lift and move heavy scrap metal easily and efficiently. However, if the power suddenly fails, the magnetism disappears instantly, which can be dangerous. This is why safety systems are very important. In conclusion, our model shows how electricity can create magnetism and help make heavy lifting easier.
Okay, I will continue with our verse from Surah Al-Hadid. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم وأنزلنا الحديد فيه بأس شديد ومنافع للناس صدق الله العظيم. So, the translation is, and we send down iron with its great might, benefit for humanity. So, our crane uses electromagnetism by running electricity through a wire coiled around a nail. We create a temporary magnet that can pick up and drop metal object at the flip of a switch. In our INAQ reflection, we look at Surah Al-Hadid. Allah mentions that iron has great might. The accurate knowledge of magnetism allows us to unlock this might in the form of electromagnetic force. This knowledge is a benefit for the people, as it allows us to manage resources and clean our environment through recycling. Now, we have almost reached the end of our video. So, to conclude, without magnetism, heavy industrial work would be slower and more dangerous. From efficiency in scrap yards to safety in steel production, magnetism is essential. That's all from us. Thank you for watching this video.